In electrical installations, particularly when dealing with main lug-only panels or MLO panels, understanding the National Electrical Code or NEC requirements for wiring methods is critical. The key difference in acceptable practices often hinges on whether the panel is located indoors or outdoors. When an MLO panel is mounted inside a house with the main disconnect located outside, specific rules apply to how conductors enter the panel. According to the NEC 300.7, wiring in concealed locations must be installed in raceways, cables, or other approved enclosures. The interior of a house is considered a concealed location. Therefore, individual conductors must be protected. This is why the use of RX connectors is mandated for metal non-metallic sheath cable entering the panel. These connectors provide the necessary insulation and protection for the wires. With 12-2 RX connectors, the maximum number of conductors permitted is 4. This is because each 12-2 cable contains 2 current-carrying conductors, a neutral conductor, and a ground conductor, totaling 4 conductors per cable. Using a 2-inch male adapter at the top of the panel for bringing wires into the panel is not permitted. This is because it does not provide the necessary insulation and protection for the wires as required by the NEC in concealed locations. The conductors could be subjected to physical damage, and the lack of proper insulation could create a fire hazard. Now, let's consider the scenario where the panel is mounted on the outside of the house. The NEC 312.5 C allows the use of nipples with bushings for conductors entering enclosures from the outside. This is permitted if the conductors are protected from moisture and physical damage. In this situation, the wires are already protected by the RX connectors and the bushing provides additional protection at the point of entry into the panel. The primary difference between the two scenarios, indoor versus outdoor panel installations, lies in the location from which the wires are entering the panel. Indoors, the location is considered concealed, thus requiring a higher degree of protection, necessitating the use of RX connectors. Outdoors, the wires are entering the panel from a non-concealed location, providing greater inherent protection from moisture and physical damage. Therefore, the code allows the use of nipples with bushings. This distinction reflects the NEC focus on ensuring electrical safety based on the specific environmental conditions and potential risks associated with different installation locations. In summary, firstly, when installing an MLO panel indoors with the main disconnect outside, all metal non-metallic sheath cables must terminate in RX connectors to provide the necessary protection for the conductors in a concealed location. Secondly, a 2-inch male adapter is not a suitable alternative as it does not offer adequate insulation and protection. Thirdly, for panels mounted outdoors, a nipple with a bushing is permitted because the external environment is not considered a concealed location and the conductors are already protected by the cable sheath and bushing. Fourthly, always refer to the latest edition of the NEC and local amendments for specific requirements and consult with a qualified electrical inspector to ensure compliance with all applicable codes and regulations. Understanding these nuances in the NEC can help ensure safe and compliant electrical installations, reducing the risk of electrical hazards and ensuring the long-term reliability of the electrical system. Additional consideration should be given to proper grounding and bonding techniques. Grounding ensures a low impedance path for fault currents to return to the source, tripping the circuit breaker or fuse and disconnecting the circuit. Bonding connects all metallic parts of the electrical system together, creating an equipotential plane and minimizing the risk of electric shock. Use appropriately sized grounding and bonding conductors and ensure they are securely connected to the panel enclosure and grounding electrode system. Another vital aspect of electrical safety is proper wire management within the panel. Overcrowding the panel with too many wires can lead to overheating and potential insulation damage. Neatly arrange the wires inside the panel, using cable ties or other approved methods to keep them organized and prevent them from coming into contact with sharp edges or other components. Proper labeling of circuits is also essential for easy identification and maintenance. Use a circuit directory to clearly label each circuit breaker or fuse, indicating the area or equipment it serves. This will save time and prevent confusion when troubleshooting or making modifications to the electrical system. Always de-energize the circuit before working on any electrical components. Use a voltage tester to verify that the circuit is dead before touching any wires or terminals. Never assume that a circuit is de-energized even if the breaker is switched off. Lockout-tagout procedures should be implemented to prevent accidental re-energization of the circuit while work is in progress. Wear appropriate personal protective equipment, including safety glasses and insulated gloves, when working on electrical systems. Avoid wearing jewelry or other metallic objects that could come into contact with energized parts. Work in a well-lit area and keep the work area clean and free of obstructions. If you are not comfortable working on electrical systems, or if you are unsure about any aspect of the installation, consult with a qualified electrician. Electrical work can be dangerous, and it is always best to err on the side of caution. Ensure that all electrical components and equipment are approved for use in the specific application and environment. Use only listed or labeled products that have been tested and certified by a recognized testing laboratory. Do not use counterfeit or substandard products, as they may not meet safety standards and could pose a serious hazard. Regularly inspect the electrical system for any signs of damage or deterioration. Look for cracked or frayed wires, loose connections, corroded terminals, or other problems. Address any issues promptly to prevent them from escalating into more serious hazards. Keep electrical panels and equipment clean and free of dust, dirt, and debris. These contaminants can accumulate over time and cause overheating or other problems. Use a vacuum cleaner or soft brush to remove any buildup of dust or dirt. Ensure that all electrical boxes and enclosures are properly closed and secured. Open or damaged enclosures can expose live electrical parts, creating a shock hazard. Replace any missing or damaged covers or doors immediately. Educate yourself and others about electrical safety. Learn about the common electrical hazards and how to prevent them. Share this knowledge with family, friends, and co-workers to help create a safer environment for everyone. If you encounter any electrical emergencies, such as a fire or shock, call for help immediately. Do not attempt to handle the situation yourself unless you are properly trained and equipped. Know the location of the nearest fire extinguisher and how to use it. Consider installing arc fault circuit interrupters or size to protect against arc faults, which can cause electrical fires. ASIs are designed to detect dangerous arc faults and trip the circuit breaker, preventing a fire from starting. ASIs are required by the NEC in many areas of the home, particularly in bedrooms and living areas. Ground fault circuit interrupters, or GFCIs, protect against ground faults, which can cause electric shock. GFCIs are required by the NEC in wet locations such as bathrooms, kitchens, and outdoor areas. They are designed to detect small ground faults and trip the circuit breaker, preventing a potentially fatal electric shock. Surge protective devices, or SPDs, protect against voltage surges, which can damage sensitive electronic equipment. SPD are designed to divert excess voltage away from the equipment, preventing damage from lightning strikes, power outages, or other electrical disturbances. Consider installing SPD at the service entrance and at individual circuits to provide comprehensive surge protection. Use the correct size and type of wire for each circuit. The NEC specifies the allowable ampacity of different wire sizes based on the type of insulation and installation method. Using undersized wire can cause overheating and potentially lead to a fire. Ensure that all wire connections are tight and secure. Loose connections can cause arcing, overheating, and voltage drop. Use the appropriate tools and techniques to make secure connections, such as wire connectors, crimp terminals, or soldering. Avoid overloading circuits. Each circuit breaker or fuse is designed to protect a specific amount of current. Overloading a circuit can cause the breaker to trip or the fuse to blow. If you are frequently tripping breakers or blowing fuses, you may need to redistribute the load or add additional circuits. Consider using energy-efficient lighting and appliances to reduce the overall electrical load on the system. LED lighting and Energy Star appliances consume less electricity than traditional incandescent lighting and appliances, saving energy and reducing the strain on the electrical system. Have a qualified electrician inspect the electrical system periodically to ensure that it is in good condition and meets all applicable codes and standards. A professional inspection can identify potential problems before they become serious hazards. Keep accurate records of all electrical work performed on the system, including permits, inspections, and repairs. This documentation can be helpful for future maintenance and troubleshooting. If you are planning any renovations or additions to your home, consult with a qualified electrician to ensure that the electrical system is adequate to handle the increased load. A professional electrician can assess the existing system and make recommendations for upgrades or modifications as needed. Be aware of the potential hazards associated with buried electrical cables. Before digging in the yard, call 811 to have the utility companies locate and mark any underground utilities, including electrical cables. Avoid digging near marked cables to prevent damage and potential electrocution. Never run extension cords under rugs or carpets. This can trap heat and create a fire hazard. Use extension cords only temporarily and unplug them when not in use. Do not daisy chain extension cords together. This can overload the circuit and create a fire hazard. Use a power strip with a built-in circuit breaker to protect against overloads. Keep electrical cords away from water and other liquids. Water can conduct electricity and create a shock hazard. If an electrical appliance falls into water, do not touch it. Turn off the power of the breaker and then remove the appliance from the water. Teach children about electrical safety. Explain the dangers of electricity and how to avoid them. Keep electrical outlets covered with child-proof covers when not in use. Do not allow children to play with electrical cords or appliances. Be cautious when using electrical appliances near water, such as in the bathroom or kitchen. Never touch an electrical appliance while you are wet or standing in water. Use a hairdryer or other electrical appliance with the GFCI protected outlet. If you are working on an electrical project that requires a permit, obtain the necessary permits before starting work. This will ensure that the work is inspected and meets all applicable codes and standards. When replacing electrical devices, such as outlets or switches, use the same type and rating as the original device. Using the wrong type of device can create a safety hazard. If you are unsure about which type of device to use, consult with a qualified electrician. Always follow the manufacturer's instructions when installing or using electrical equipment. Failure to follow the instructions can void the warranty and create a safety hazard. Be aware of the signs of electrical problems, such as flickering lights, sparking outlets, or a burning smell. If you notice any of these signs, investigate the problem immediately and consult with a qualified electrician. Never attempt to repair electrical equipment unless you are properly trained and qualified. Electrical repairs can be dangerous and should only be performed by a licensed electrician. Keep a flashlight handy in case of a power outage. A flashlight can help you navigate in the dark and avoid accidents. Consider installing a standby generator to provide backup power in case of a power outage. A standby generator can keep essential appliances running and prevent food spoilage. If you are using a portable generator, operate it outdoors in a well-ventilated area. Carbon monoxide from the generator exhaust can be deadly. Install carbon monoxide detectors in your home to alert you to the presence of carbon monoxide. Test the detectors regularly to ensure that they are working properly. Be aware of the potential hazards of static electricity. Static electricity can ignite flammable materials and damage sensitive electronic equipment. Take precautions to reduce static electricity, such as using anti-static sprays or wearing cotton clothing. When working with electronic equipment, use a grounding strap to discharge static electricity before touching any components. Avoid using electrical appliances during thunderstorms. Lightning strikes can cause power surges that can damage electronic equipment and start fires. Unplug sensitive electronic equipment during thunderstorms to protect them from damage. Be aware of the potential hazards of overhead power lines. Avoid contact with overhead power lines when working outdoors. Keep ladders, antennas, and other equipment away from power lines to prevent electrocution. If you see a down power line, stay away from it and call the power company immediately. Never touch a down power line as it may be energized. Teach children to stay away from power lines and substations. These areas can be dangerous and should be avoided. Be aware of the potential hazards of electrical fires. If an electrical fire starts, turn off the power at the breaker and call the fire department immediately. Use a Class C fire extinguisher to put out the fire. Do not use water on an electrical fire, as water can conduct electricity and create a shock hazard. Be aware of the potential hazards of electrical shock. Electrical shock can cause serious injury or death. Avoid contact with energized electrical parts and take precautions to prevent electrical shock. If someone is being electrocuted, do not touch them. Turn off the power at the breaker and then use a non-conductive object such as a wooden broom handle to separate them from the electrical source. Call for medical assistance immediately.